Hello students, welcome you all. So now we are going to discuss exercise 8.2 of your book, page number 15. So see question number 1. ABCD is a quadrilateral in which P, Q, R, S are midpoints of sides AB, BC, CD and AD respectively. See in this figure. AC is a diagonal. Okay, here you can see. So S, R, Q, P are the midpoint of side AD, DC, CB and AB respectively, and AC is the diagonal. Okay, what we have to prove? So this much data is given. Okay, so first part is SR parallel AC. Look at the figure. SR parallel AC. So first we will prove that I. Here in the triangle DAC, in triangle DAC, what we have? S is the midpoint of AD, or you can write DS equal to AS. Similarly, DR equal to CR, DR equal to CR, or you can say R is the midpoint of CD. Therefore, ASR must be parallel to AC. So you can directly write so ASR parallel AC. You can give mention that it is midpoint theorem. Midpoint theorem. So your first part is solved. And yes, another thing, SR is equal to 1 by 2 AC. Also you can directly write and SR equal to 1 by 2 AC. This is also your midpoint theorem. Now we'll move to double I part. Here you see PQ equal to SR. Okay, PQ, where it is? PQ equal to SR. Okay, similarly we will see in triangle ACB or ABC. Again, in triangle ABC, similarly you can write AP equal to BP, AP equal to BP, or in other word you can write P is the midpoint of AB and Q is the midpoint of BC, or you can write BQ equal to CQ. Okay, therefore PQ equal to 1 by 2 AC. So PQ equal to 1 by 2 AC. Now you see SR equal to 1 by 2 AC and PQ is also equal to 1 by 2 AC. Therefore also PQ equal to SR. This is what we had to prove, PQ equal to SR. So now we have proved it. Okay. Now again we will move to the triple I part. Here you have PQ equal to SR. Look at the figure. SR equal to PQ. If we can prove SR is parallel to PQ, then PQRS will be a parallelogram. Here SR is parallel to AC. SR parallel AC. Similarly, PQ parallel AC. PQ parallel AC. So SR must be parallel to PQ. SR parallel PQ. Now you see SR is parallel to PQ and SR is equal to PQ. And you can write and SR equal to PQ. So PQRS is a parallelogram. Hence solved. Okay. So we have proved that PQRS is a parallelogram. Now we'll move to the next question. Here you can see the next question. ABCD is a rhombus. Look at the figure. ABCD, it is a rhombus. And PQRS are the midpoints of side AB, BC, CD and DA. You can see PQRS, they are the midpoints of side AB, BC, CD and AD. So that quadrilateral PQRS is a rectangle. We have to prove that PQRS is a rectangle. So you can write the given what are given. Now first we will prove that PQRS is a parallelogram. Then we will try to prove that PQRS is a rectangle. We will take triangle ABC, this triangle. In triangle ABC, P is the midpoint of AB. You can write P is midpoint of AB. Similarly, Q is the midpoint of BC. You can write Q is midpoint of BC. Therefore, PQ parallel AC. So, PQ parallel AC. Similarly, SR must be parallel to AC in triangle ADC. You can write in triangle ADC. AS equal to SD, or AS is the midpoint of AD. You can write AS equal to SD, or DS you can write. RD equal to RC, or DR equal to CR. DR equal to CR. So SR must be parallel to AC. SR must be parallel to AC. Now you see PQ parallel AC and SR parallel AC. You can write it statement 1 and statement 2. From these two statements, so you can write, so PQ must be parallel to SR. PQ parallel SR. Similarly, now PQ is parallel to SR. Similarly, you can prove that PS is parallel to QR. Similarly, PS parallel QR. Now you see PQ parallel SR, PS parallel QR. Look at the figure. PQ parallel SR and PS parallel QR. So therefore, PQRS is a parallelogram. Now we have proved that PQRS is a parallelogram. Now what we have to prove? PQRS is a rectangle. Okay, now you see ABCD, it is given that ABCD is a rhombus. Here can write ABCD is a rhombus. So this angle must be what? 90 degree angle. You can name it. Say suppose we'll name here M and name this point N. Okay, this point is O. So angle MON, angle MON equal to 90 degree. Okay. Now you see MQ is parallel to ON. MQ parallel ON and NQ parallel OM. NQ parallel OM, isn't it? Now this AC is parallel to PQ, therefore ON must be parallel to MQ. Similarly, QN must be parallel to MO, or OM parallel NQ. Therefore, MQNO, this figure MQNO must be a parallelogram. You can write, so ONQM we can say. ONQM is a parallelogram. Here you have angle MON equal to 90 degree. Here we have written, but angle MON equal to 90 degree. So the opposite angle must be 90 degree, as MONQ is a parallelogram. So angle MQN you can say, angle MQN equal to 90 degree. Now we have PQRS is a parallelogram. We have proved that PQRS is a parallelogram. Now one of the angle is 90 degree. Therefore you can directly write, therefore PQRS is a rectangle. Or you can give a region here, as one of the angle is 90 degree. So PQRS is a rectangle. Okay, so this is your proof, question number 2. Now we'll move to question number 3. ABCD is a rectangle and PQRS are the midpoint of side AB, BC, CD and D respectively. Look at same thing here. ABCD is a rectangle, it is given to us. PQRS are the midpoint of these four sides. So that quadrilateral PQRS is a rhombus. We have to prove that PQRS is a rhombus. This figure PQRS is a rhombus. That means we have to prove PQ equal to QR equal to RS equal to PS. Okay, first same thing here. First we will prove that PQRS is a parallelogram. Okay, so let's start. Here we'll take same triangle ADB triangle or ABD triangle. In triangle ABDD, S is the midpoint of AD. S is midpoint of AD. Similarly, P is the midpoint of AB. P is midpoint of AB. Okay, therefore you can say SP is equal to 1 by 2 BD. SP equal to 1 by 2 BD. Okay, similarly we will move to this triangle. Okay, triangle BCD. In triangle BCD, R is the midpoint of CD. R is midpoint of CD, or you can write DR equal to RC also you can write. And Q is the midpoint of BC. Q is midpoint of BC. Therefore RQ equal to 1 by 2 BC. RQ equal to 1 by 2 BC. Okay, right. RQ equal to 1 by 2, not BC, it's BD. This RQ is equal to 1 by 2 this BD. Okay, we will write it statement 2 and last write it statement 1. Okay, similarly we can prove ASR equal to 1 by 2 AC. ASR equal to 1 by 2 AC, and you can write it statement 3. And PQ equal to 1 by 2 same AC, statement 4. Now you see ABCD is a rectangle. It is given to us. ABCD is a rectangle. Therefore what will happen? AC must be equal to BD. Diagonals of a rectangle are equal, but you can write but AC equal to BD implies that 1 by 2 AC must be equal to 1 by 2 BD. Now you see 1 by 2 AC, 1 by 2 AC, here 1 by 2 BD, 1 by 2 BD. Here you have written that 1 by 2 AC equal to 1 by 2 BD. Therefore RHS of all the statements, statement 1, statement 2, statement 3 and statement 4. Remember RHS, RHS of all the statements, statement 1, 2, 3, 4 are same. So therefore all the edge RHS are same, LHS must be same. Therefore SP equal to RQ. So you can write SP equal to RQ equal to SR equal to PQ. Now in a quadrilateral, if 4 sides are equal, then what will happen? It must be a rhombus. So PQRS is a rhombus. Okay, here we have proved that PQRS is a rhombus, or in other words you can also first prove that this is a PQRS is a what here parallelogram. Then you can prove that it is a rhombus. As all the sides are equal, you can directly write it is a rhombus. Okay, now in question number, we'll move to question number 4. Here you see question number 4. ABCD is a trapezium. Here you see ABCD is a trapezium in which AB is parallel to DC. So AB is parallel to DC. BD is a diagonal. Here you can see BD is a diagonal, and E is the midpoint of AD. Here you can see E is the midpoint of AD. That means ED equal to AE. A line is drawn through E. A line is drawn through E point parallel to AB. Parallel to AB. AB is here. A line is drawn through E parallel to AB like this. This line intersecting BC at F. Intersecting, where is BC? BC. Okay. at F, at this point is F, so that F is the midpoint of BC. So we have to prove that F is, this is what we have to prove, FC equal to FB. Okay, this is what we need to prove. Okay, so let's start. So first we write what is given. Given that ABCD is a trapezium, DC is parallel to AB, and E is the midpoint of AD. Okay, you can write what are given. DC parallel AB, DE equal to AE, DE equal to AE, this much is given to us, and also it is given that EF parallel AB, EF parallel AB. Okay, now you see EF is parallel to AB. Now we will take this triangle, triangle DAB, in this triangle, in triangle DAB, in this triangle E is the midpoint of AB, E is midpoint of AB, and EG parallel AB, EG parallel AB. Okay, therefore G must be the midpoint of BD or DB. So you can write, so G is midpoint of BD. Why? Give reason. Theorem 9, it's 8.10. 8.9 is your midpoint theorem, 8.10 was this theorem. Okay, now we have got G is the midpoint of BD. Therefore you can say GD equal to BG. You can write it GD equal to BG. Okay, now we will take to this triangle, triangle BCD. Now in triangle BCD, in this triangle what is there? This DC must be parallel to FG, DC parallel GF, you can write parallel GF, and G is the midpoint of BG, or you can write GD equal to BG. Okay, now these two sides are equal, and DF is parallel to DC, therefore F must be the midpoint of BC. So F must be the midpoint of BC. Okay na? So here you have F is the midpoint of BC. So that F is the midpoint of BC, this is what we needed to prove. So we proved that F is the midpoint of BC. Now we will move to the next one. Question number 5. In a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively, so that the line segment AF and EC trisect the diagonal BD. So what is given to us here? Given to us is ABCD is a parallelogram, F is the midpoint of CD, E is the midpoint of AB. Now we will try to prove that AECF is a parallelogram. Okay, let's try it. Here AB is parallel to DC, AB parallel DC, so AE must be parallel to FC, so AE parallel FC. Okay, similarly we have to prove that AE equal to FC. Again DC equal to AB, DC equal to AB. Why? Because ABCD is a parallelogram. You can give the reason. Implies that 1 by 2 DC equal to 1 by 2 AB, implies 1 by 2 DC is your AE. No, 1 by 2 DC is your FC. FC equal to 1 by 2 AB. Look at the figure. 1 by 2 AB is your AE. Okay. Now you can write statement 1 and this is your statement 2. So from these two statements, statement 1 and statement 2, look at the figure. AE is parallel to FC and AE is equal to FC. So you can write, so from statement 1 and 2, AECF is a parallelogram. AECF is a parallelogram. So AF must be parallel to EC. So AF parallel EC. Now we'll take this triangle APB triangle. In triangle APB, look at the figure APB. APB, this triangle. E is the midpoint of AB. E is midpoint of AB. Okay, and AP is parallel to EQ. AP parallel EQ. Why? Because AF is parallel to EC, therefore AP must be parallel to EQ. Okay, therefore Q must be midpoint of PB. So Q is midpoint of who? Q is the midpoint of BP. So you can write, so PQ equal to BQ. PQ equal to BQ. You can write in statement 3. Now again in triangle, this triangle DQC or CDQ, you can say in triangle CDQ. Similarly we have PF is parallel to QC. PF parallel QC, and F is the midpoint of CD. F is midpoint of CD. Yes, CD. Therefore P must be the midpoint of DQ. So P is midpoint of DQ. Now you have, if P is the midpoint, therefore DP must be equal to PQ. So DP equal to PQ. Okay, now you can write it statement 4. From statement 3 you can see PQ equal to BQ. Now you can see PQ equal to DP. So PQ equal to BQ, PQ equal to BQ equal to DP. Now look at the figure. PQ, this part, equal to BQ, this part, equal to DP. Therefore it is proved that this AF and EC will trisect BD. This is what we needed to prove. Hence you can write hence proved. Okay, this is what we needed to prove. Now we'll move to question number 6. So that the line segment joining the midpoints of opposite sides of a quadrilateral bisect each other. Okay, very nice. So let's try to solve it. What is given to us? Midpoints of opposite side of quadrilateral. Midpoint of AB is P, midpoint of DC is R, similarly midpoint of AD is S, and BC midpoint is Q. Here what we have to prove? PR, this line PR and SQ, they will bisect each other. Okay, you know that in a parallelogram diagonals bisect each other. Sorry, diagonals bisect each other. Now if we can prove that PQRS is a parallelogram, then definitely it will be proved that PR and SQ will bisect each other. So first of all we need to prove that PQRS is a parallelogram. Okay, let's try it. Here we will take two triangles. Triangle first we will take ABC triangle. ABC triangle. In this triangle, in triangle ABC. What we have? P is the midpoint of AB, or you can write AP equal to BP. AP equal to BP. Similarly, BQ equal to CQ. BQ equal to CQ. So, or therefore, PQ must be parallel to AC. So, PQ parallel AC. Write it statement 1. You can give the reason, midpoint theorem. Again, in triangle, on the another triangle we will take ADC or ACD. In triangle ADC, we have S is the midpoint of AD, or you can write AS equal to DS. AS equal to DS. Similarly, DR equal to CR. DR equal to CR. So, therefore, SR must be parallel to AC. SR parallel AC. Write statement 2 and give the reason that due to midpoint theorem. Now, from statement 1 and from statement 2, here you can see PQ is parallel AC and SR is parallel AC. So, from statement 1 and 2, PQ must be parallel to SR. PQ parallel SR. Okay. Now, similarly, we can prove that. Now, what we have proved? PQ is parallel to SR. Similarly, we can prove that SP parallel RQ. Similarly, SP parallel RQ. Therefore, now you see, in a quadrilateral, opposite sides are parallel. So, you can say PQRS is a parallelogram. So, therefore, PQRS is a parallelogram. Okay. So, here we have PQRS is a parallelogram. Now, you see, PR and SQ are the diagonals. Here, PR and SQ, PR this line and SQ this line are the diagonals. And diagonals of a parallelogram bisect each other. Hence proved. Okay, this is what we needed to prove. Now we'll move to the last one. ABC is a triangle, right angle, let's see. Now you see, in this triangle, ABC is a triangle, right angle, let's see. A line through the midpoint M of hypotenuse AB. So hypotenuse AB you can see, and line through midpoint M. So M is the midpoint, therefore BM equal to M. And parallel to BC intersect AC at D. So a line through midpoint M parallel to BC intersect AC at D. So therefore you can see MD line is parallel to BC line. Okay. Now we have to prove this match is given to us. What we have to prove? D is the midpoint of AC. D, this D point is the midpoint of AC. So let's start. Okay. Here you see M is the midpoint of AB in triangle ABC. M is the midpoint, or you can write MB equal to MA. MB equal to MA, and MD is parallel to BC. This is given to us. MD parallel BC. So, or therefore, D is the midpoint of AC. So, D is midpoint of AC. Why? Theorem 8.10. Okay. Now what we have proved? We proved the first part, I part. I is being proved. Now we'll move to the double I part. MD is perpendicular to AC. MD, look at the figure. MD is perpendicular to AC. Now we have proved that it is given to us that MD is parallel to BC. Therefore, this angle BCA, angle BCA equal to 90 degree given to us. Angle BCA must be equal to angle MDA. This angle BCA equal to angle MDA. Why? Corresponding angle. Now you see, this angle is 90 degree and both angles are equal. Therefore, angle MDA equal to 90 degree. So you can write angle MDA equal to 90 degree. This is what we needed to prove. MD parallel AC. Therefore, also you can write MD perpendicular to AC. Now we will move to the triple A part. Triple A part, we have to prove that MA equal to MC, MC equal to MA equal to 1 by 2 AB. MC, look at the figure, MC equal to AM or MA, these two are equal to 1 by 2 AB. Okay, for that we have already that M is the midpoint, therefore BM is equal to AM. This is what we have. We need to prove that CM is equal to AM. How we can prove? If we can congruent triangle CDM and ADM, then it can be proved. Now in triangle CDM and a triangle ADM, we have one angle 90 degree. Okay, we have CD equal to AD, and we have DM or MD is common side. So side angle side. Okay na? First we write CD equal to AD. CD equal to AD. Angle CDM equal to angle ADM equal to 90 degree, you can say, and MD equal to MT. Therefore angle CDM, so triangle CDM will be congruent to triangle ADM. Region is side angle side. Okay, now we have congruented. Now so that CM must be equal to AM, so CM equal to AM, region CPCT. Okay, so CM equal to AM, we needed to prove that CM equal to AM. Half the thing we have already proved. Now you have that AM equal to 1 by 2 AB, as M is the midpoint, just write that, but AM is the midpoint, therefore AM equal to 1 by 2 AB, so AM equal to 1 by 2 AB implies, or therefore you can write this statement, you can write CM equal to AM equal to 1 by 2 AB. So CM equal to AM equal to 1 by 2 AB, hence proved. Okay, so this is the end of this exercise. Please complete the exercise. We will have a test on Monday. Okay, thank you.